Okay, YouTube, in this video what we're going to do is we're going to explore the basic premises or basic characteristics of the graph of y equals cotangent of x. And we're going to change this to a cotangent here. But basically, explore the basic characteristics of y equals cotangent of x and then determine how we could graph these more generally using what we call the framing method. So let's go ahead and start by taking a look at this basic shape of our cotangent curve. And this is kind of a little subsection of the curve that you're seeing here. But when it comes to actually making this, what we're going to do is we're actually going to create a table of values. And so I do want to do this. We say if x is our angle and y is our cotangent value, let's remember that if y equals the tangent of x is equal to sine of x over the cosine of x, then what this means for our cotangent graph, y equals the cotangent of x, is that it's going to be the cosine of x over the sine of x. And so what we're going to see is a situation here where when we evaluate these on our unit circle, it's going to be an undefined function wherever our sine function has a value of 0. So in terms of what angles would give us a sine of 0, we could say, well, 0 radians gives us a sine of 0. We can see that here. We could also see that if you were to go over to pi radians over here, we have a sine value of 0. So we're going to see a situation here when we start dropping in angles. We'll start at 0. We'll go up by pi fourths. So 0 pi fourths, 2 pi fourths, which is pi halves, 3 pi fourths, okay, and then 4 pi fourths, which is just going to be pi. I suppose I'll just write a pi here. I'm just going to leave it at this, but we're going to take a look at these here. We say that if we wanted to find our cotangent values, again, sine, remember tangent, remember that our tangent values on the unit circle can be found by taking the y value divided by the x value. So on the unit circle, if the tangent of theta is equal to y over x, then we know that the cotangent value of theta is equal to x over y. And so our cotangent value at 0 would be 1 over 0, x over y. And so what we're going to get is a situation where we start off with an undefined point. Now going to pi fourths, we say x divided by y here. Well, something divided by itself is 1. How about at pi halves? Well, pi halves, when we look up here, we say x divided by y. This would be 0 over 1. That's a 0. At 3 pi fourths, so over here at 3 pi fourths, we're going to see that we get x over y is really something divided by itself, but we have a negative divided by a positive, so we get negative 1. And then when we come back to pi, what we're going to get is we're going to get negative 1, which is our x value, divided by 0, which is our y value. And negative 1 divided by 0 is also undefined. And so what I want everybody to see is that if we were to keep going, x divided by y here, if we were to keep going around by pi fourths, we would get something divided by itself is positive 1. If we go down to here at 270 or 3 pi halves, we get 0 divided by a negative 1 is 0. And then if we come back over to here, we get something divided by itself, but positive divided by negative is negative 1. And then we come back to 0, we get 1 divided by 0 is undefined. So what we're going to see is that our cotangent graph is always going to repeat itself in the period distance of pi. And so one thing we want to make sure that we write here for our cotangent graph is that the period of the function is pi, or more generally speaking, when we start to determine it from our function here, we're going to say instead of 2 pi over b, it's just going to be pi over b. So you'll notice that on my illustration here, we say that the period of this function is pi. Now, if we were to construct a graph from this, and I really just am going to borrow from our table here to look at this graph up here, what we're going to see is that at our undefined spots, which are at 0, we have an asymptote that runs here, and then also at pi, which is what this x value is here, we say that we have an asymptote on our graph. So between these two asymptotes, directly between these two asymptotes, what we get is a situation where at pi fourths, which is going to be halfway between 0 and pi halves, we're at a height of 1. At pi halves, we're at a height of 0. And at 3 pi fourths, we're at a height of negative 1. And we get this graph that between these two asymptotes is always decreasing. So let's write a few notes here. We say, first of all, that we have a cotangent graph that is always decreasing, whereas our tangent graph was an always increasing graph. As a matter of fact, when we compare the graphs of tangent of x, which is what you see here, y equals tangent of x, to the graph of y equals cotangent of x, we can see that tangent of x and cotangent of x are really related. It's just that cotangent of x is an always decreasing graph, where tangent is always increasing, okay? And they're also out of phase with one another, but here's what we want to look at. Essentially, that our cotangent graph looks like our tangent curve. So with respect to constructing this, one important thing that I want to point out here is that directly in between these two asymptotes, directly between them, we have a 0 in the middle of our frame. And so just like with our tangent curves, we say right in the middle of our frame here, we can see that our tangent curve, its frame, right in the middle of those two asymptotes is a 0. And so the same thing is going to be true about our cotangent graph. directly between these two asymptotes is a 0. Okay. So with respect to our frame here, constructing our frame for a cotangent graph, the neat thing about making our cotangent graph is that the starting point of our frame, we're going to write this down here, starting point is at C over B comma D, starting point. And so we get C over B comma D. So this is always consistently our starting point. It's just that with cotangent, unlike tangent, our starting point is not going to be in the middle of the frame. Our starting point is actually just like we traditionally have it on the left side of our frame here. So with respect to amplitude, because our cotangent graph here has no max and no min, it will have no amplitude. But with our frame here, that absolute value of A is still going to determine the height of our frame. So with our cotangent graph here, we can see that our A value is 1. You can see that our frame here above our starting point goes up 1, and below our starting point goes down 1. Okay. With respect to the period, we say that the period is pi over B. In this particular case, we see that we have a B value of 1. So we say the period of this particular graph should be just pi over B, which in this case comes out to be pi. And so the length of our frame, you can see that the length of our frame here is pi units. And so once we've constructed our frame, here's how this works. We'll get our midline, and then we'll split it in half and split our halves in half. But the key points, the 5 key points that we're going to see of every cotangent graph within a frame are these. We say that our asymptotes, our vertical asymptotes, lie at the edges of the frame. So of our 5 key points, we would say that these asymptotes represent 2 of those 5 key characteristics of this graph. The other 3 key characteristics, or 3 key points, come at these parts of our frames. And so what we see is a situation where directly between the 2 asymptotes we have a 0. And this will always be the case, that our cotangent and tangent graphs between the 2 asymptotes will always pass through this midline here right in the middle. So with respect to these other 2 points, because cotangent is always decreasing, and because this absolute value of A still determines the height of our frame, I can tell you that with our frame here, our cotangent graph at its 1/4 of mark will always pass through this part of its frame, and at 3/4 of the way through its period here, it'll pass through this here if it is unreflected. And so we get this cotangent graph that if we just connect the dots here, we can see, runs between these asymptotes and is always decreasing here, and we would get this graph that looks like this. So with respect to creating a sketch of, say, a cotangent graph here, what I've got, let me just kind of readjust here, is with our graph of y equals a cotangent bx minus c plus d, what we're going to do is we're going to determine the absolute value of A, the period length, and then the starting point of our frame. So let's start with the absolute value of A. Now in this case our A value appears to be 2, so we say the absolute value of A in this case is 2. That is not the amplitude. As a matter of fact, we're going to write that this has no amplitude. So with respect to the period, now remember that with tangent and cotangent, these are the only 2 graphs that have a period of just pi. Every other trig function has a period of 2 pi. So we say pi divided by b in this case. If we're going to do pi divided by b, looks like our b value here is just pi itself. So when we take pi divided by pi, an interesting thing happens here. We get a period of just 1. And so now our starting point, let's go ahead and work this out here. We say c over b comma d. Now with respect to our c value here, it looks like we have no c value being added on or subtracted off our x on the inside of these parentheses, so our c value must be 0, and our b value here is pi. So we get 0 pi. This is our horizontal shift, and then our vertical shift here is just d, and it looks like we have a d value of -2. So our starting point here is going to be at 0 comma -2. Now I'm going to put boxes around all of this information, because here's what we're going to do first. Scrolling down, let's take a look. If we were to create this cotangent graph, the very first thing we want to do is go ahead and throw on our starting point, and we observe that our starting point is this point 0 comma -2. So let's get our frame rocking here. We say if we were to go down 2, okay, then this would be the starting point of our frame, and this is at the point 0 comma -2. There we go. So now looking at the rest of this graph, we just need to construct the rest of our frame now, remembering that this is unlike tangent in that our starting point is actually on the left side of the frame. So when we go ahead and construct our height here, the absolute value of A was 2. This means we're going to go 2 above. Okay, let me switch back over to a red here. We're going to go 2 above with our frame and 2 below this height. So if we go 2 below, it looks like we're going to reach a minimum height of -4 here. Or at least I shouldn't say minimum, but our frame reaches a minimum height of -4. So we have the height of our frame. Now we need to go out 1 period length, and it looks like the period here is just 1. So because we're starting in an x value of 0, I'm going to say, well, arbitrarily, how about we just call this 1 right here? It seems that our frame would run out to the side here, and looking at this, we can go ahead and construct our midline. We can split this in half. This would be the x value 0.5. We could split these halves in half. So this would be the x value 0.25. I suppose I could write this here. I want to write that here. 0.25, and this would be 0.75. But here's our frame. So to construct our cotangent graph, the neat thing about it is what we need to do is start by constructing our two consecutive asymptotes. These occur at the edges of the frame. Directly between two asymptotes, we see that our cotangent graph always passes through this middle quote-unquote 0 point. And because our a value in this case, when we look at our a value is positive 2, it means that our cotangent graph is not going to be reflected over the x-axis. So we are going to get this always decreasing graph, and the reason why that's so important is because if I were to have an always decreasing graph, I suppose that I could either put a point here on the frame here and down here, and we would get a decreasing graph, or we could switch these around and say that this point must be down here and this point must be up here on our frame, and we get an always increasing graph. Because it's not reflected and because cotangent is always decreasing, I'm going to go ahead and put those points there on our frame, and what we see is a situation that looks like this. So we would say that here is our cotangent graph, and if we wanted to do this, we could say to the left, go -1. We could extend our frame to the left here and see how we could just come up with another cycle of this. We would have another asymptote at the edge of this frame here, splitting this into quarters. Okay, we would see that we have a 0 here. And because it's always decreasing, we say it must be up here to the left of our 0 and down here to the right of our 0. Here's another cycle of this graph here. Okay. So that's basically the basic shape of our cotangent graph and how we could use the framing method to also graph those without making a mistake. Cheers.